42. Rank the compounds in each of the following groups in order of increasing acidity or basicity as indicated, and then explain the order you assigned. And then we have letter B. So in this case, we have to, rank the compounds in terms of basicity, and then they give us 4 different, molecules here: H2O, OH minus, H minus, and Cl minus. Okie dokie. So the first thing is I'm just going to write up my little chart here, right? If we want to go from increasing basicity, that means that we have to go from the least basic. So we have least basic on the left side, and then as we go and move to the right, we become the most basic. So we'll say most basic. Okay. So I think as of now, we've been talking mostly about acids, not really bases. Now, if we want to know the general basicity trend, and this is for basically binary bases, right? Not bases that stem from oxoacids. So just, regular bases. Your bases will always increase, basicity will always increase as you go up a group and to the left of a period. So basically, as you go up and over, you're going to be the most basic. So essentially, let's just put these over here, right? Let's just figure out the ranking system first. Now, for these, right, we're going to usually rank in terms of all the elements that are not hydrogen, because hydrogen is the one that basically is the same for both acids and bases, right? The hydrogen is the one that's donating or being donated or accepting, right? So for H2O, I'm going to look for oxygen. Then I have oxygen again. Now in this case, in these two, I only have a hydrogen, so I have to look at the hydrogen here. And then I have just a chlorine. Now if I figure out where those elements are, hydrogen is all the way over here. Oxygen is over here, and then chlorine is a little bit below it. So, in terms of our scale, we increase as we go up. So it seems like all the ones that are on the higher tiers would be more basic than this chlorine, right? I got to go up to oxygen from chlorine, and then I got to go over. So chlorine would be the least basic. So maybe I'll write that in blue. So the chlorine one would be the least basic. So we're starting off with Cl minus. Now, if we're increasing and increasing all the way to the left, the hydrogen would be the most basic, right? If I'm increasing all the way this way, hydrogen would be the most basic in this terms, H minus. So we figured out H minus, we figured out Cl minus, but now we just have basically the same element. We have H2O versus OH minus. Now, remember, acids always have one more hydrogen than their conjugate bases. The only difference between H2O and OH minus is that they have a difference of one hydrogen. H2O would be the acid, and OH minus would be its conjugate base. These are conjugates of each other. So maybe I'll just put conjugate, or conj for short. This one has to be more basic because it's losing, or it lost, one more hydrogen. So the OH minus would be over here, and the H2O would be on the lesser basic side. The OH would be on the more basic side. And now we just have to write our little greater than or less than. So since we're going from least to most, we draw less than symbols. Cl minus is less than H2O, which is less than OH minus, which is less than H minus. And that is your trend. So maybe if I just box this off, here is the answer. And now, there's just a couple of reasons as to why this is the answer, right? They do say explain the order. Well, you can talk about the trend, but this basically comes from a little bit of electronegativity and a little bit of stability. I drew the electronegativity chart over here, which means that as you go up the group, you increase in electronegativity, and as you go over, you also increase. So from going upward, basically, more electronegative. If you're going by a group, you will be more basic. However, the less electronegative So we'll say the electroneg, right, Neg, element in terms of a period is also the least stable when holding a negative charge. So if you're not electronegative, chances are you don't want to be negative, right? So all of these, hydrogen, especially hydrogen minus, right? It doesn't want to be this. It's the least stable. That's why it's the most basic. It will want to accept a hydrogen as soon as possible. On the flip side, Cl minus, remember Cl minus comes from HCl, and if you are a really, really, really strong acid, your conjugate is going to be so weak that it's basically neutral, aka the least basic. So hopefully this makes sense. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel, and I will see you all later. Okay, bye-bye.